Today, we're descending into the hidden heat beneath California's crust, exploring the mysterious hot springs suddenly boiling beyond their usual limits. The scientists racing to understand the data, the microquakes and gas emissions signaling a deeper shift, and the creeping thermal pulses that could reshape landscapes and ecosystems. By the end of this video, you'll never think about California the same way again. Before we dive in, make sure you hit subscribe, because the geothermal anomalies we're uncovering today are only the beginning. You don't want to miss what's heating up beneath the surface. Something strange is happening beneath California. It started quietly, with scattered reports from hikers east of Fresno. They noticed the roadside hot springs felt different, almost angrier. What were once gentle, steaming pools began showing unpredictable surges, spitting mud and steam with a new intensity. These early whispers, passed along by word of mouth, were the first signs of a geological mystery unfolding across the state, long before official instruments began to register the anomaly. Scientists soon confirmed what the hikers had suspected. Across a vast stretch of California, from Lassen Peak down to the Owens Valley, hot springs were getting hotter. Water that normally hovered around a comfortable 40 to 50 degrees Celsius was now pushing past 70. In some high-altitude pools, the water was nearing its boiling point, creating an immediate and hidden danger for unsuspecting visitors. What was truly baffling was that these temperature spikes were happening simultaneously in springs separated by hundreds of kilometers. This wasn't a local issue. It was a sign of something much deeper and far more widespread. To understand what's happening, we have to look at California's volatile foundation. The state is a complex web of volcanic fields and fault systems. We all know about the San Andreas Fault, but there are also dozens of active and dormant volcanic centers, like the massive Long Valley Caldera and the Geysers Geothermal Complex. Normally, geothermal surges are contained events, isolated to a specific volcanic field. But the simultaneous heating across such a huge area was unprecedented. It was as if an invisible network was carrying heat far beyond its usual boundaries, connecting these disparate geothermal hotspots in a way scientists had never seen before. As official investigations ramped up, eyewitness accounts continued to pour in, painting an even more alarming picture. Backcountry campers near Mount Shasta recorded creek temperatures soaring to nearly 80 degrees Celsius. Rangers in Death Valley, a place synonymous with extreme heat, noted steam vents hissing back to life for the first time in over a decade. Meanwhile, high above the Earth, satellites were detecting subtle but consistent ground uplift. Across multiple geothermal regions, the land was swelling by fractions of an inch, a telltale sign of pressure building from below. All this evidence pointed to one conclusion. This wasn't just surface-level weather or a minor geothermal fluctuation. This was a regional thermal anomaly, driven by heat moving up from deep within the Earth's crust. Analysis of the spring water confirmed this. The mineral composition had changed, showing higher concentrations of deep-source minerals and trace gases that could only come from a deep, pressurized system. It seemed that ancient fractures in the rock were being forced open, creating new pathways for superheated fluids and gases to race toward the surface. Beneath the ground, another story was being written in the language of earthquakes. Sensitive instruments began picking up swarms of microquakes, tiny tremors rippling along the San Andreas Fault and its associated systems. These weren't the jarring quakes Californians are used to. These were different, consistent with the movement of hot fluids through rock. Their distribution was diffuse, scattered across the same regions experiencing the heat spikes, signaling a widespread thermal pulse. Near Mammoth Lakes, an area with a history of lethal carbon dioxide emissions, some homeowners even reported faint, rolling tremors and a noticeable increase in CO2 levels in their homes, a chilling echo of past geological events. The rising heat wasn't just a geological curiosity, it was beginning to have a tangible impact on the environment. Creeks fed by geothermal runoff saw their temperature skyrocket. In one creek west of Bishop, the water temperature jumped from a brisk 10 degrees Celsius to over 30 degrees in just a few kilometers. This sudden warming had a devastating effect on aquatic life. Native trout, struggling to breathe in the oxygen-depleted water, were seen clustering in any small, cool pocket they could find. These anomalies were a clear sign of an ecosystem under severe stress. hinting at the potential for long-term ecological damage if the trend continued. To get a clearer picture of the phenomenon, scientists turned to deep boreholes drilled into the Long Valley caldera. What they found was startling. The temperature gradients were inverted. Typically, the ground gets hotter the deeper you go. But here, the deepest layers were warming faster than the shallower ones. This meant the heat wasn't just seeping up, it was rising as a sustained plume, pushed upward by immense pressure building in a confined chamber miles below. This was accompanied by the detection of trace sulfur compounds and erratic CO2 fluctuations, creating what geologists called a stacked anomaly, a confluence of signals all pointing to a dynamic and highly pressurized underground system. The danger soon became undeniable. Near Mono Lake, a hiker was severely burned after stepping into a hot spring that had, without warning, heated to well above its normal temperature. The area was immediately closed to the public. Officials cited unexpected environmental conditions, but public warnings about the underlying geological risks remained limited, perhaps to avoid widespread panic. In the absence of clear information, rumors and speculation began to swirl online. People debated whether this was a precursor to a volcanic eruption, a sign of major fault instability, or somehow connected to geothermal energy operations in the region. The truth, for now, remained just out of reach. In response, government agencies have dramatically increased their monitoring efforts. The landscape is now dotted with an array of new instruments: temperature loggers, gas sensors, and highly sensitive ground deformation monitors. Satellite imaging continues to show the ground swelling, sometimes by several millimeters in just a few weeks, which suggests the process is not slowing down and may be driven by forces originating deep in the Earth's mantle. Experts emphasize that while the sustained underground pressure is a serious concern, it doesn't necessarily mean an eruption is imminent. The Earth is a complex system, and these pressures could dissipate slowly over time. But the truth is, we are in uncharted territory. The scale of this thermal anomaly is unprecedented in modern scientific record. We are witnessing a fundamental shift in the geological behavior of one of the most dynamic regions on the planet. The heat beneath California is rising, and while scientists work to decipher its meaning, one question hangs in the air. Is this the slow, quiet awakening of a sleeping giant? We can only watch, wait, and listen to what the Earth is telling us. Thanks for watching. If you found this journey into California's geology fascinating, be sure to subscribe for more deep dives into the mysteries of our world.